Okay, hey folks, Mark Locklear here with a quick screencast on Chapter 11, and this is how to create databases, tables, and indexes. Nothing really groundbreaking here. Hopefully, a lot of this should already make sense. We've gone through the process of setting up some of our own databases, so uh, you could have, up to this point, you could have very easily have run those scripts like without looking at them, but although I think I did, I think you have done some modifications to them to fit the database server and the database names we're using. So hopefully, you just didn't go in there and just make those changes. Hopefully you've sort of looked, you've looked at them a little more broadly. But this this chapter basically goes in and digs deeper into sort of each one of those. So just going to go through these and sort of hit the hit the high points. And as always, if you have questions, you can let me know. Obviously, to create database statements, often you'll see this if exists or if not exists. Basically, the idea here is you want a script that can, from a repeatability standpoint and from a you need some checks and balances in there. That's probably not the right term, but the example I'm looking at here is this is the create DB EX. I think this is the example database that Murach uses. But without this drop table or drop database if exists statement, if the database was already there, the script would error out, right? And it would just stop at that point. Like, just so you understand the way SQL scripts run, if there's an error at any point, you can have warnings and the script will continue to run. But if there's an error at any point, the script just stops at that point. It won't proceed. So you sometimes have to build in these little checks. So the idea here is so it'll run, it won't just die. So, in this case, before it goes in and tries to create the EX database, it's going to check if it exists first. And then obviously we've got a use statement. And, a lot of this stuff is the same, some of the same commands we've been running locally at our own command line. And then you can see, of course, there's insert statements and other things you see. So again, most of that should be fairly straightforward. Tables, same rules apply. You can also check if a table exists before you create it. Often, at least the ones we've seen up to this point, it's just at the database level you're doing that, because if the database exists, you're sort of assuming that all those tables are going to exist too. But you can code in things like dropping a database first. Often a dangerous thing to do, so you need to be careful about that. But anything you run at the command line, you can also run inside an SQL script too. Okay, we've talked some about not null, not null, unique values, default values, auto increment. Again, we covered this in the chapter when we talked about data types. So again, all of those things are available to you and are important when you're running either create a database and create table scripts. Primary key constraint. So we've talked, somewhat about primary key constraints here, but often the way these constraints work is that we've talked about referential integrity some up to this point. So again, in the example of having a vendor and an invoice, the relationship between, a vendor can have many invoices, with these constraints in place, if you try to delete an invoice, you can't delete that invoice, or I'm sorry, yeah. So for a vendor and invoice, if you try to delete a vendor, but there's an invoice for that vendor, then you'll actually get an error because there's some checking that's going on. MySQL won't allow you to remove a vendor if it has an associated invoice with it. The idea is, we've talked about this idea of having orphaned records. So in that case, again, if you deleted a vendor who has an invoice, then you've got an invoice that is in this sort of orphaned status. That is, when we say orphan, we mean there's this parent here, or this parent relationship that would no longer exist. So that's what these constraints can do for you. Foreign key, so we've talked about that. So again, this is setting up that relationship between two tables and values in those two tables. So again, the example they use here, again for the invoices table, invoices references vendor. So the invoices table has a vendor ID, has an invoice ID, and also a vendor ID. The vendor ID points back or references the vendor's table, and so that sets that relationship up there. And then so this relationship is on both sides of the relationship. So here we see, yeah, so having that foreign key constraint here too, you can see again that stops this issue of having orphaned records in a given table. Again, you wouldn't be able to delete a vendor if it had invoices associated with it. Okay. Alter table. This is pretty straightforward here. Again, all of the commands that are available to you when you run a create statement, you can also run alter commands on those also. So again, whether it's changing a name of a table, changing a value type, changing a constraint, any of those things, you can run the alter. You can use the alter keyword to change those things either at the table level or at the database level. Again, just big caveat is, the big warning is, obviously you need to look at, especially if this is a production database, you need to do your research first. You need to do your testing first. In a true production environment, you would have a staging or a testing environment in place that is going to be an exact copy of what your production environment is. You're going to make the changes in that testing environment first. You know, again, if you're going to be modifying either databases or tables, you're going to go in and make those changes and then run tests. You really should need to have a set of tests in place, whether they're manual tests or automated tests. So you would actually run the alter table or alter database statements, and then you might have a dozen or more queries that you would go in and run, and obviously that's going to be based on your knowledge of the database. And again, if I know I'm going to be modifying the invoices table, then obviously the tests that I want to run are going to be around the invoices table and any relationships that might affect the invoices table. So I've got some sample select queries. Let's say I'm gonna run. I've got some sample join statements that I'm going to run, and make sure those queries run. If those queries reference an old table name or an old field that has been changed by the alter statement, then obviously you need to go in and update those. So again, a lot of work goes into, if you've got a production environment and you're going to be modifying or changing the state or any of the attributes related to the database, you need to take copious amounts of time to go in and do those tests first, because a lot easier to do those tests first and then deal with any issues you might run into, rather than to just willy-nilly make changes to production database, run into major issues, and then have to roll that back. And I guess the rollback part of this is a big one too. Always have a sort of worst case scenario plan in place, a plan B or C, where, okay, I can quickly roll this back. So not only are you testing the implementation of an alter statement on your database or your tables, but okay, I would have, the way I would do it is I would have a script in place that I could very quickly run a second alter statement that's going to essentially roll back the changes that I made and take the database back to the previous state that it was already in. So that way you're ready for that. You've got a plan in place in case, a worst case scenario plan where, okay, this is having some unintended consequence we didn't plan for. You can quickly roll back and make the database look the way it did previously. So again, these are just, showing more alter statements. Again, the syntax and the keywords are the same as when you're initially creating them. You're just you can use the alter statements to go in and change those. Renaming, truncating, or dropping a database. Again, if it's not already obvious, these are very dangerous. These are very dangerous commands to run. I mean, you need to run them from time to time, but again, planning is key. If you're going to be dropping a database, obviously that means dropping. Like there is no, trash bin like there is in Windows where you can get a database back. When it's gone, it's gone. Now you may be running on a cloud service that may have, snapshots are a pretty popular feature these days. Essentially, it's just what it says. It's a snapshot of your server at a point in time. So often it's important to run snapshots. You can do backups too. MySQL has the ability to back up a database. So obviously running a backup like that prior to dropping, and really any of these things that you're doing, if it's any kind of alter statements or anything that you have a danger of losing data or significantly changing the structure of the database, always worth doing a backup first. And you probably want multiple backups. I mean, for me and a production database that's critical to whatever service or job the folks you're working for do, I would probably have an SQL dump in addition to at the server level taking snapshot. So you've got lots of options to be able to roll back, in case if you run into a worst case scenario. Indexes, indexes have always sort of been a black box to me. I always feel like I don't understand them as well as I should. So, and here they don't dig really deeply into what they are. Just know that the handful of things that you'll want to know are that primary keys are always indexed. So an index is just a quick way to search a given column in a table. So generally primary keys are always important because those are the references between two tables. So by default, primary keys always get indexes, and then you can index other columns or other fields in other tables based on your needs. Now, how do you determine when that is? Well, it often depends on the queries you're running. If there's a query that references a particular table on a regular basis, then having an index on that particular field is a smart way to go. And again, I mean, the overall point here is this is basically my understanding of an index. I'm a little outside of my sort of comfort zone in saying this, but I feel this is my understanding is essentially it creates a cache in memory of a given field. So rather than the database, if you search a certain table in a certain field, rather than it having to sort of start at the top and just go down and search through a table, it's already got a cache of memory on a given field or set of fields. And so that's how the index is able to speed up the search, and by as a result of that, speed up the queries that are run based on a particular field. And so, yeah, this just walks you through the syntax for an index statement. And like, this is the kind of thing where if you were creating an index for a particular field, like if you've got a particularly slow query that's running, you're going to want to do your research on that query. Number one, make sure the query is optimized. But number two is a potential solution. You say, okay, I think maybe what we want to do is add an index to a particular field. So what you would do is, again, I've talked about production versus testing or staging environments in the past some, but essentially you would run this query in your production environment, then you'd go to your testing environment. Again, your testing environment should be a clone. It should look just like your production environment does. And you would make modifications to the database. And like, again, in this case, let's say you were going to create an index to see if you could speed a query up. You would, you would run a query on the production database, see how long it takes for that query to run. And then after creating an index or making some modifications on your testing environment, you would run the same query there and just compare those two and see if you're getting a significant gain in speed on how fast a query is being run. Okay, scripts that create database. Again, I mean, I've got up here in the background, this is the create script for the example database. And, again, generally you're going to run these, drop table if it exists. You're going to create the database, you're going to run your use statement. And at that point, again, standard create table statements along with fields and data types, and then any constraints like null or not null or anything like that you might want. And then also you can have insert statements there too. So again, just sort of depends on what the needs are. And in fact, I'm going to be asking you to do one of your assignments this week is to make some modifications to the committees table. And you're going to be hopefully drawing on chapter 10, some of our database design skills that we use there to add one or more, add a couple more additional tables, and then also inserting some data into that table. So this talks about MySQL Workbench. So yeah, I mean, we're not using Workbench in here. These tools are really similar. Again, I mean, you'll want to read over this because you might get some questions on the quizzes about these. But whether you use MySQL Workbench, whether you use PHP MyAdmin, there's a bunch of different GUI tools out there that allow you to interact with the database rather than using command line. And my goal in us doing everything via the command line in this class rather than using a GUI tool like this is, if you learn it at the GUI or if you learn it at the command line level, actually making modifications there, it's a very easy jump from there to here. In fact, you'll sort of, using a tool, having done it at the command line will really make you appreciate using a GUI tool like this if you choose to do that. Foreign keys. So this section on character sets and collations, again, they go into the details here. Most of the time you're taking whatever the default is. I mean, if you're in the United States and you're working for a U.S. company, probably you're going to use the standard INNODB database. That's the default. I think it's after 5.6 or 5.7. MySQL 8 is what we use now. And so these character sets just do, again, they're sort of the underlying wiring for characters. And we generally here in the States, we're using standard English language and standard keyboards, but it's just important to understand that you've got, we've got dozens and dozens, if not hundreds of other languages around the world. And there are character sets for each of those countries and their associated languages that go along with them. And so if you're working, and listen, these days in a global marketplace like we are, wouldn't be uncommon for you to be working stateside and you're working for a remote company who has customers in, South America, Asia, the Middle East, and there are different character sets for all of the IT applications those folks use. So it's not, it wouldn't be out of the question that you would be asked to work in an environment where you would need to deal with these things. Generally, there's not a lot of maintenance. This is generally done at the database level, and once a database is set at that level, then the commands you're using, the create table statements, alter table statements, the queries, all of that stuff still applies. But it's just important to know that these character sets exist, how to choose them, how to create them, how to modify them. I've had scenarios before where we were trying to import data from one database from another database into a new one, and there were some character set issues because the character sets were different. So that might be a scenario where you would have to, you would need to have knowledge about these things to be able to export and then import data from one version of a character set to another. You can run some of these commands. I think you all probably should have the right to do that. You could run these on our server just if you're curious about the character sets we're using. I'm thinking UTF-8 is probably what it is, and then again it should be the INNODB although I'm not 100% sure about that. When I set the database up that you are using, I just took the defaults. I just took the defaults across the board. You know, they mentioned storage engines here, and so right, that's the other. Here's the INNODB that I referred to again, character sets and storage engines. It's almost inevitably going to, certainly any greenfield application. When I say greenfield application, I mean if you're starting a new application from scratch and building it up, INNODB is what you're going to use. You may run into some ISAM stuff if it's an older version of MySQL, and there are plenty of older versions of MySQL out there. I did some work in the past few years on an open source project, still used, still use MySQL 5.7, I think. So there, those things are certainly out there. Bunch of different settings here with regard to, the amount of bytes. When we looked at the character sets, the number of bytes that they use, those kinds of things. Again, there's a bunch of little nuances. You just need to know that those are issues. So from a planning perspective, again, thinking about a greenfield application, if you're planning a new app, based on the amount of data that you might be storing in that database, that could have a significant, even a byte or two per field could have a significant impact long term on the amount of storage that it maybe takes to store all the data that you're trying to work with. So alrighty, that is all. I think I'm just going to stop there. Again, basically everything you do with regard to creating databases, tables, setting fields, doing all those things, you've got alter statements that allow you to change all those things. Indexes, we talked about, again, those things are going to be, those things are important for the speed of queries, especially with, especially depending on the amount of data you got. The larger the database sets you've got, the more being able to optimize queries is going to be very important. And then the last section on character sets and storage engines. Again, we're not going to do a bunch of exercises. In fact, I don't think I have any exercises related to those things, but again, worth knowing about, if you go on to do great things in software development and on the database side. Many times you can just take whatever the default sort of settings or the default install settings for MySQL are. But again, at the database administrator level, when you're a DBA, that's like you're the girl or guy that's responsible for that particular piece. You're going to want to be aware of things like character sets, storage engines. Just make sure there's a good chance that the defaults are going to be good enough and they're going to serve your needs, but depending on the special needs that a particular application might have, then that may be something you'll want to modify. Okay, that's all for now. Good luck, and let me know if you have questions.